and welcome to the Swedish Pavilion in Dubai at Expo 2020. We are going to talk about space today. My name is Mathias Sundin. I'm the founder of the World Space Program and of the Warp Institute.
And my name is Olsson, and I'm also a member of the World Space team, and I also work a bit with space startups.
So we're going to talk about this question you see behind us here. Should we fix Earth before we go to space? That's the most, if you're involved in anything in space, you get asked that question
all the time. And it is a focus on the week here as well now, because we're going to be talking about space and sustainability within the whole week in Dubai.
Yes, so we're going to dive into this topic a bit, and I'm going to show you that this is actually a false choice. We don't have to choose Earth or space. We can choose both, and we're going to explain a little bit why here in this session. If you want to check out more about Warp, you can go to warpspaceprogram.org or warpnews.org, where you can find fact-based, optimistic news on technology, science, and human progress. And space, of course, is a big part of all three of those.
It's incredibly important for us to make sure that we have an optimistic community, because these are the people that are going to move everything forward and make the future in space come sooner.
The future is created by optimists, and the mission of the Warp Institute is to make the future come sooner. So if we gather a lot of optimistic people in one community, we can really make the future come sooner. But today we're going to focus on space, and this question: should we fix Earth before we go to space? And I want to start with a survey we did. We asked people this question, 500 people, and what they believe. And as you can see here behind me, 39% disagrees with the statement, before we go to space, we should fix the problems on Earth. 39% disagree, but that means 61%
more than half agree that we shouldn't worry too much about space.
Yeah, and like I said before, I think that's the false choice. You don't have to make this choice, even though people ask this question a lot, people involved in space. I'm going to give just two examples. There are many examples of this, but I'm going to give you two examples why I think this is a false choice. So first, you see behind me here, that's from Allen Coral Reef, Allen Coral Atlas. So what they're doing is they have satellites in space, looking down on Earth, taking images of the seas in this case. And they can see from above when a coral reef started to change color, because when it goes from all those beautiful colors and starting to change into white, that's when the reef is starting to die. And 25% of all species on Earth live in coral reefs. 25%. That's similar to the Amazon rainforest, for example.
And I mean, this is something that would be incredibly difficult to do from Earth, right? To get this sort of overview.
Exactly. If you want to survey, if you want to check the status of a coral reef, you have to go there. You have to go there by boat, probably fly to somewhere in the middle of nowhere in the Pacific. You have to go by boat. Maybe you have to dive down and measure it, or you can send out a drone, something like that. It's complicated. It takes a lot of resources, money, but also time and effort to do that. So it's not impossible, but almost impossible to do that on a weekly basis. No one would spend that amount of money. But with a satellite, you can do that. So with a satellite, you have those, you can have it almost in real time, or at least just a few days apart, and see progress over time, how things are changing or not changing. And this is because of satellites, and the cost of satellites, launching satellites, are going down, and that the satellites become better and better, and cheaper and cheaper. So,
and this you could use for other ecosystems as well, I suppose, forests. There must be many examples.
Yeah, absolutely. You can use this for many applications. This kind of satellite imaging. You can watch human rights activists use this to see what dictatorships do against their citizens, for example. Or you can watch forests and you can see fires early on. A number of things you can use it for. That would be very hard or nearly impossible and very expensive if we did it another way. So that was the first example. The second example is this. I don't know if you can see the tiny solar cells. This is on Vanguard 1, a very early US satellite called the grapefruit by the Soviet Union. You know, they were first on Sputnik, so they call this the grapefruit.
So here we have those little dots there, those are solar panels.
They're solar panels, small solar panels, and solar cells were developed just 3 or 4 years before this happened, but no one really bothered much with it. But NASA saw an opportunity to get energy, electricity in space, and so they started developing this, spent money on this over many decades when most people ignored solar cells. And today we see solar cells everywhere. We see it, of course, at the International Space Station. And we see it here at this enormous solar farm that's being built here in the UAE. Because the price of solar cells have dropped dramatically, 99% since we saw that one, and over the last decade it dropped more than 85% in cost. And this is because you took those early costs early on from NASA and the space community.
So now this is something that can be used even on a personal basis. As a person, I have my own solar power to charge what I need on my daily life. So things have really changed from being a little tiny part of the satellite to being a part of our daily life.
Exactly, and this is often the case when you use space or when you develop technology for space. So in space there are often extreme conditions. It could be very, very hot if you're close to the sun, or it could be very, very cold. And that could be just a few hours apart. So the material has to be really resistant, the technology has to handle those tough things, impacting them over many, many years or decades even. So when you develop technology for space, you have to do the extreme version. And that's of course expensive, and you have to push technology really forward. But then we can use it on Earth, because that is much cheaper and better, and we don't have to use the extreme case, we can use some sort of lighter version of it, with solar cells, for example.
So in looking at this, maybe it's possible that the technology that we need to fix Earth has already been constructed.
Yep, we just need to make it, always make it better and cheaper, so it's more accessible to everyone, but that's what's going on all the time. But so these are two examples of technology, but of course there are other things we can learn from space to fix problems on Earth. Another is this.
Yeah, I mean, obviously technology is super interesting and it's something that drives us, but another one that we need to take into consideration is behavior. And one of the things that we can learn from living in space is, as you can see here on this photo, it's an extreme environment. And it's also incredibly expensive to bring the resources you need. So we often talk about the astronaut lifestyle, and basically what that means that it's not allowed to be any waste. Everything that you use has to, in some way, be able to be reproduced, reused, and recycled. So being an astronaut, you only use the amount of water that you need, the amount of food that you need. And this is something that the extreme conditions that we're living under now, maybe we can adapt in some way in our lifestyle. Do I really need to use all the water I need and all the energy that I use today? If we cut down and if we're a bit closer to this astronaut lifestyle, then we can really make a difference.
And the first step is probably then knowing how much how much water do we use, how much waste, how much food, all those things. So you can start measuring, okay, can I lower this 10%?
And what kind of things can I do? If you're up on an International Space Station, they're always experimenting on how can I grow my own food, like what kind of steps can we take to limit how much resources that we use. So there's a lot to learn from the astronaut lifestyle as well.
So the conclusion here is that we need space to fix problems on Earth. We can do it otherwise, but it will be much, much more expensive and much, much harder. So if you hear the question or the statement, we should fix our problems on Earth before we go to space, you know that's a false choice now. We need space to fix problems here on Earth. Otherwise, it will be very, very much harder. Just imagine the thing that we haven't mentioned at all, climate change. How would we know so much about climate change without satellites? We will know a lot less, so we can do a lot less about it. But with space, we have the opportunity.
Exactly. This is all about how we use the technology that we have been developing. And this is up to us now. The technology is there, the behavior changes are there. Let's just make the most of it together.
And this is what we call the optimist's edge. So if you have a fact-based, optimistic view of the world, You see behind the headlines, you see the negative headlines about in news media, but you look behind them and you look at the facts. So you're informed of what's really going on in the world. You don't have this super pessimistic view of what's happening in the world. So you see those opportunities and you understand this is a false choice. But we do this in many areas, in space, but also other areas. We look at optimistic edges you can get in your life and for knowledge or start companies or, in various ways make the future come sooner. So please check out warpnews.org and sign up as a premium supporter and you'll get the Optimist's Edge. So that's it for us from Dubai today, Expo 2020.
And we have more exciting things to come in the week. So we'll hope to see you again soon. Thank you very much.
Thank you very much.
Thank you.